Welcome to the Deep Dive. You're tuning in because you're wrestling with a crucial question. What's the best Ruby application server in, well, 2025?
Right. It's a common one.
Maybe you're prepping for a big technical decision, or perhaps you're just, curious about what makes your Ruby apps tick under the hood. We've got a fantastic resource, a really comprehensive guide that lays out the landscape from the rack-solid veterans to the lightning-fast newcomers.
Yeah, it's a good one. It really digs into how things have changed.
So our mission today is basically to boil down that guide, extract the vital insights, and hopefully give you a clear path forward in understanding this critical piece of your Ruby infrastructure.
Exactly. And this guide, it isn't just a list of servers. It really illuminates how the demands on Ruby applications have shifted.
Okay.
And how these servers have adapted or, been built from the ground up to meet those new challenges.
Right.
What's really interesting is seeing the trade-offs each option presents. Performance, architecture, even how you deploy your app, it's all connected.
Okay, let's unpack this then, starting with the names you probably already know. First up is Passenger, or Fusion Passenger.
Ah, Passenger.
The guide calls it battle-tested, and it's famous for playing well with the big web servers like Jinx and Apache. What makes Passenger such a go-to for so many people?
Well, think of it as the dependable workhorse, Its biggest strength is probably how easy it is to get started.
Easy setup. Okay.
Yeah, for a lot of teams, it's like the quickest route to getting a Ruby app live in production. It's also got this reputation for being stable, something you definitely appreciate when things get busy.
Stable is good.
Plus, it has some smarts built in for managing memory, which can save you headaches down the line. And it's not just for Rails, it supports other Ruby frameworks too, which is a nice bit of flexibility.
Great.
And if you need enterprise-level support, that's also an option with Passenger. They have that commercial offering.
Dependable is good. But what are the catches? The guide hints at a few limitations, doesn't it?
Right, it does. The guide points out that if you need all the bells and whistles, some of the more advanced features, well, they require commercial license.
Ah, okay. Paywall for some features.
Exactly. It also notes that compared to some of the newer servers we'll talk about, Passenger can sometimes use more memory, which can add up, in larger deployments. And if you're chasing absolute top-tier performance, the benchmark suggests there are, frankly, faster options out there now.
Okay, makes sense. So next in the traditional camp is Puma. Now, this is the one most Rails developers will recognize, right?
Oh, yeah, definitely. It's been the default since Rails 5.
It's become a real standard. What are its core strengths?
Puma really leans into handling a lot of requests at once, concurrency. It uses threads, like multiple lanes on a highway, to process incoming traffic within a single process.
Okay.
It can also run in clustered mode, which we can get into more detail later, but it allows you to spin up multiple independent processes.
Right, scaling out.
Exactly. The guide highlights that it's generally pretty lightweight on memory, which is always a plus. It's actively being developed, so you know it's keeping up with the times.
That's important.
And the documentation is excellent, which developers really appreciate.
Yeah, good docs are key.
We even see a typical config snippet in the guide showing how you can set the number of threads and workers you can think of threads as how many tasks each worker can juggle simultaneously.
Okay.
And that preload out instruction is also pretty key. It's like loading the application into memory once so that when new workers start up, they're ready to go much faster, saves time.
So if it's the default and has all that going for it, where might it fall short? What are the downsides?
Well, the guide mentions a crucial point. Because Puma uses threads, your Ruby code has to be thread safe.
Ah, right. Thread safety.
Imagine if multiple threads tried to change the same piece of data at the same time without coordination, things could get messy fast.
Yeah, race conditions and stuff.
Exactly. Also, Ruby has something called the Global Interpreter Lock, or GVL, or GIL, depending on who you ask.
The infamous GVL.
Right. Think of it as a rule that only one thread can execute Ruby code at any given time within a single process. This can limit how much Puma can actually take advantage of multi-core processors in really high-load scenarios.
So true parallelism is limited within one process.
Precisely. And finally, getting the absolute best performance often involves some manual tweaking. Tuning the number of workers and threads to match your specific application and server resources. It's not always set and forget.
Okay, so those are the established players. Now let's explore these modern alternatives the guide talks about. They sound interesting.
Yeah, this is where things get pretty different architecturally.
First up is Falcon, which is described as a really fast server built with something called async Ruby. That sounds like a different approach altogether. What makes it stand out?
Falcon represents a pretty fundamental shift in how a Ruby server handles requests. Being built from the ground up for HTTP2 is a big deal for modern web apps.
Right, efficiency gains there.
Yeah, it allows for a more efficient transfer of data between the server and the browser, multiplexing and all that. But the really interesting part is its use of fibers for concurrency.
Fibers. Okay, not threads or processes.
Kind of. Imagine fibers as super lightweight threads that can pause and resume execution without the heavy overhead of traditional OS threads or processes.
Lighter weight, you mean?
Much lighter. This allows Falcon to handle a massive number of concurrent connections with very low latency, making it particularly well suited for things like WebSocket applications.
Ah, real-time stuff.
Exactly, where you need those persistent lightning-fast connections. The configuration example in the guide really highlights this asynchronous nature and its focus on HTTP2 using the async library.
This fiber-based concurrency sounds like it could offer some serious performance gains, especially for I/O-heavy apps.
Potentially, yes. Very much so.
What are the trade-offs then when you go with a newer option like Falcon? Is it all upside?
Well, no, not quite. As the guide rightly points out, because Falcon is newer to the scene, it hasn't been, let's say, battle-tested in as many diverse, high-pressure production situations as Passenger or Puma.
Less time in the trenches.
Exactly. The community around it is also smaller, which could mean fewer readily available resources or shared experiences if you run into tricky issues.
Right. Community support matters.
And importantly, it requires Ruby 3.0 or later. That might mean an upgrade is necessary for some existing applications before you can even try it.
Okay, good point. Next in the modern category is iodine, another server that puts a big emphasis on WebSocket support, apparently.
Yes, iodine is interesting because it tries to bridge the gap maybe between the older way of doing things with HTTP 1.1 and the more modern real-time needs of applications with WebSocket.
So it handles both well.
It supports both right out of the box, which is a huge plus if you need that real-time communication alongside standard HTTP. The guide also mentions it has built-in PubSub.
PubSub, like Redis, but built in.
Sort of, yeah. Like a built-in messaging system that can simplify building features like live updates or notifications within the server itself.
Interesting.
And to get its performance edge, it uses native extensions. Think of these as pieces of code written in C, a faster, lower-level language.
Okay, speed boost from C.
Right. And it's designed to be very memory efficient. We even see an example in the guide of how simple it is to just flip a switch, basically, to enable HTTP2.
Simple config is nice.
And for WebSocket, the code snippet shows how you can pretty easily define what happens when the server receives a message and how to send data back. It seems quite integrated.
Sounds like a powerful tool, especially for those real-time applications. What keeps it from being, more widely adopted? Are there drawbacks?
Similar story to Falcon, really. Iodine has a smaller community and less extensive documentation compared to the big players like Puma. The guide also points out that there aren't as many large-scale production deployments showcasing its capabilities yet, which might make some teams a bit hesitant for really critical applications. Less proven, perhaps.
Right, the proven in production factor.
Yeah.
Okay, the last of the modern alternatives the guide highlights is Agoo. It calls it a high-performance Ruby web server. What's its main draw?
Agoo is all about speed, pure and simple speed.
Just raw performance.
Yeah, the guide really emphasizes its raw performance numbers and mentions that it's specifically optimized for GraphQL, which is, increasingly popular for building APIs these days.
Optimized for GraphQL. Interesting.
It's also designed to have a very small memory footprint and a straightforward setup. Focus on speed and efficiency.
So if you need maximum speed and efficiency, especially with GraphQL, Agoo might be the answer. What are the potential downsides? Can't just be speed, right?
Well, the guide notes that Agoo has a more focused, maybe limited feature set compared to some other servers.
Okay, less bells and whistles.
Exactly. And its ecosystem and community are still relatively small. It also hasn't seen as much widespread adoption in large production environments. So similar trade-offs to the other newer options in some ways.
Okay, we've got a good overview of the main players now. Let's talk about what really matters to a lot of people. Performance.
Right, the benchmarks.
The guide includes some interesting benchmark results for how many requests per second these servers can handle. Simple Hello World app, I think, What do those numbers tell us?
Yeah, it's a basic benchmark, but it really illustrates the potential differences. Agoo comes out on top in that test, handling around 7,000 requests per second.
Wow, 7,000.
Yeah. Closely followed by Falcon at 6,000 and iodine at 5,500.
Still very high numbers.
Definitely. Then you have Puma running with 4 workers in that test configuration, handling about 4,500 requests per second, and Passenger Enterprise processes around 3,000.
So quite a spread.
It's a significant difference. These numbers really highlight the potential for significantly higher throughput with the modern asynchronous servers, especially when dealing with a high volume of simple requests.
And memory usage is often a critical factor, right? Keeping costs down, ensuring stability. What do the guide's numbers show there?
Exactly. Memory is huge. The base memory usage figures also tell a compelling story. Agoo is the most memory efficient in these tests, using only about 40 MB.
Tiny.
Relatively, yeah. Iodine uses around 50 MB and Falcon about 60 MB.
Okay, all per low.
Then Puma uses approximately 80 MB, and Passenger is the most memory-intensive of the group at around 120 MB base usage.
So almost 3 times the memory for Passenger compared to Agoo in that baseline test.
In that specific scenario, yes. It really underscores another potential advantage of the modern alternatives. They can often do more with less in terms of server resources, especially memory.
Now, the guide also goes into the underlying architecture of some of these. Let's start with Puma's clustered mode. We touched on it, but how does running multiple Puma processes actually help with handling more traffic?
Right, so think of clustered mode as giving Puma more hands to work with, instead of just one main Puma process managing threads.
Which hits the GVL limit.
Exactly. Instead of that, you can spin up multiple independent Puma worker processes. Each of these worker processes has its own set of threads to handle requests and, critically, its own GVL.
So you bypass the single GVL bottleneck that way.
Correct. It helps you get around some of those limitations because the workload is distributed across multiple separate Ruby processes, potentially running on different CPU cores.
Makes sense.
The configuration example shows how you define the number of these workers and the threads within each worker. And that on-worker boot section is important,
Why's that?
because it ensures that resources, like your connection to the database, are properly established within each individual worker process after it starts up, avoiding issues with shared connections from the master process.
Got it. Good practice. And how does Falcon's fiber-based architecture achieve high concurrency? It sounds fundamentally different from Puma's approach.
It is quite different, yeah. Instead of relying on operating system level threads or multiple processes in the traditional sense, Falcon uses these fibers we mentioned.
The lightweight threads.
Sort of. Imagine a single thread that can very quickly switch between different tasks, different fibers, that are waiting for something to happen, like a database query finishing or a network request coming back.
So cooperative multitasking within a thread.
Exactly. These fibers are incredibly lightweight, and they yield control cooperatively. This allows Falcon to handle a massive number of concurrent, especially I/O-bound operations very efficiently within potentially just a single OS thread. It reduces the overhead associated with managing tons of traditional threads or processes.
Less context switching overhead.
Precisely. The config.ru example for Falcon in the guide shows how it integrates with the async library, which provides the foundation for this whole cooperative concurrency model.
Very cool. The guide also points out some modern features that set some of these servers apart. Let's circle back quickly to WebSocket and HTTP2 support.
Yeah, definitely worth reiterating. As we mentioned earlier, both Falcon and Iodine have built-in first-class support for WebSockets.
Baked right in.
Right. This means they're designed from the ground up to handle those persistent two-way communication channels really efficiently. We saw the code snippets showing how straightforward it seems to handle WebSocket connections in Falcon.
And the iodine HTTP2 config.
And how easily you can configure iodine for HTTP2.
Yeah.
This native support can really simplify development and often leads to better performance compared to trying to bolt these features on with external libraries or proxies.
Makes sense. Now, deployment is always a key practical consideration. The guide touches on using containers with Docker and Kubernetes. How do these different Ruby servers fit into that world? Is it pretty standard?
Generally, yes. All of these Ruby application servers can be easily packaged into Docker containers. The guide provides a common example of a Docker file for Puma, which is pretty representative.
Standard Docker stuff.
Pretty much. You start with a Ruby base image, set up your application code inside the container, install your dependencies using Bundler, and then tell Docker how to run the Puma server using CMD or entry point.
Okay.
Then, when you're using something like Kubernetes to manage these Docker containers at scale, you'll typically define resource requests and limits for your application pods.
Right, CPU and memory settings.
Exactly. The example shows how you can specify how much memory and CPU each container should ideally have requests, and what its maximum allowed usage should be, limits. That's crucial for stability and scheduling in Kubernetes.
And the guide mentioned needing a shell server.
Yeah, it makes an interesting observation that, at least for now, you often still need some way to interact with and manage your Docker and Kubernetes deployments, maybe through a CI/CD pipeline, maybe a jump box, or just your local shell with kubectl. It's not always purely automated UI clicks.
Right, makes sense. And when you're running applications in containers managed by Kubernetes, health checks become really important, don't they?
Oh, absolutely critical. Health checks are like a regular checkup for your application instances running in containers.
Tells Kubernetes if it's alive and well.
Precisely. They allow Kubernetes or your load balancer to automatically detect if an instance is unhealthy, maybe it crashed, maybe it's stuck, and needs to be restarted or removed from receiving traffic.
Prevent sending users to a dead instance.
Exactly. The guide provides a simple example of a health check endpoint, just a route like health, that returns a 200 OK status and maybe the current time, or a simple JSON payload. This simple endpoint is absolutely crucial for maintaining the reliability and uptime of your application in these orchestrated environments.
Got it. Okay, so once you're deployed and running in production, fine-tuning for performance is often necessary. What specific advice does the guide offer for optimizing, say, Puma and managing memory in general?
Well, for getting the most out of Kuma, especially in clustered mode, the guide highlights some more advanced configuration options, specifically around how it handles database connections across those worker processes.
You mentioned the on-worker boot.
Right, but also, before fork and on-worker shutdown, the examples showing these hooks are really best practices to prevent issues with database connections being shared incorrectly or not cleaned up properly between the master process and the worker processes after they're created or destroyed.
Important for database connection pooling.
Very important. Regarding memory more generally, the guide touches on the topic of garbage collection, GC tuning.
Huh.
It gives an example of setting some environment variables like Ruby GT-Pinit slots.
GC tuning. Sounds complex.
It can be, yeah. While the specifics of GC tuning can get quite technical and depend heavily on your application's specific memory allocation patterns, these settings generally control things like how much memory Ruby pre-allocates and how aggressively it tries to free up memory. Tuning these can sometimes yield performance or stability improvements, but it requires careful measurement.
So tread carefully there.
Definitely measure before and after making changes.
Okay, this has been an incredibly thorough overview. Now, for you, the listener, trying to process all this, how do you actually decide which server is the right fit for your specific needs? The guide seems to offer some clear guidance here.
Yes, thankfully it does try to boil it down. It really comes down to considering your main priorities.
Okay, break it down for us.
So the guide suggests if you need robust enterprise support, rock-solid stability is paramount, and maybe an easy, well-understood setup are your top priorities, Passenger is still a very strong contender.
The reliable choice.
Kind of, yeah. Now, if you're running a Rails application and you value a large, active community, lots of available documentation and examples, along with proven performance in countless production environments, Puma is likely your best bet. It's the safe, standard choice for Rails.
The Rails default for a reason.
Pretty much. And then, if you're really pushing the boundaries of performance, maybe you're using Ruby 3.0 or later and want to leverage fibers, or you have a critical need for built-in, efficient WebSocket or HTTP2 support, or if memory optimization is absolutely crucial for your environment.
Then look at the modern ones.
Then the modern alternatives like Falcon, Iodine, and Agoo are definitely worth a serious look. They offer potential advantages in those specific areas.
Okay, that clarifies the decision points nicely. And once you've made your choice and deployed your application, keeping an eye on its performance is crucial, right? The guide briefly mentions Prometheus and APM tools.
Exactly. Monitoring is key. Integrating with systems like Prometheus allows you to collect and monitor key metrics about your application server's performance. Things of request counts, request latency, queue times, resource usage.
Central metrics.
Yeah. The example middleware integration shows how you can expose these metrics in a format that Prometheus can scrape and understand. It's a pretty standard practice now.
And APM.
Application performance monitoring tools like New Relic shown in the example, or Datadog, Scout APM, etc., go even deeper. They provide detailed insights into your application's behavior within the request database query times, external API calls, code bottlenecks, helping you pinpoint any performance issues or errors much more effectively.
So Prometheus for the server metrics, APM for the application code itself.
That's a good way to think about it, yeah. They complement each other.
So to bring it all together, it seems that while Puma is still a fantastic and, generally applicable choice for many Ruby applications, especially Rails,
It's solid.
these modern alternatives like Falcon, iodine, and Agoo offer some really exciting performance advantages, particularly if you're taking advantage of newer Ruby features or have specific needs around real-time communication or super high concurrency.
Precisely. It's about matching the tool to the job, really. And as the guide points out, tools like DeployHQ can streamline the deployment process no matter which server you ultimately decide on.
Right, the deployment tooling is somewhat independent.
Yeah. And it's interesting to note that even DeployHQ themselves apparently rely on both Passenger and Puma internally for different parts of their own infrastructure.
Oh, interesting. So they use both.
Yeah, it highlights that there isn't always just one single best answer. It often depends on the specific service or application.
If you, the listener, want to dig even deeper into this topic, what further resources does the guide recommend? Where should they go next?
Well, the guide suggests looking at comprehensive Ruby deployment guides online for more detailed setup instructions for each server, and it also encourages reaching out to their support team, presumably the guide authors team, if you have specific questions relating to their content.
Okay, good pointers. This has been a truly enlightening deep dive into the world of Ruby application servers in 2025. It really underscores how this foundational piece of our infrastructure continues to evolve.
It really does. The landscape changes faster than you'd think sometimes.
Look, here's a final thought for you listening. Perhaps you're currently running a setup, maybe Puma or Passenger, that's served you well for years, and that's great. But take a moment to consider, how do your application's specific demands right now, your team's current expertise, and the potential for significant gains in performance or efficiency? How might those align with the strengths of these different server architectures we've discussed?
Yeah, it's worth reflecting on.
It might just spark a thought about whether it's time to revisit your current setup, or maybe even experiment with some of these newer possibilities for future projects. Food for thought. Thanks for joining us on the Deep Dive.